Hi everyone, Austin with Sun Funny Kits. So this is going to be part 2 of the benchmarking option that we're going to have um, in version 4. So in the first video we showed you how we recorded the data and we had some information here. But we had also informed you that this is not really the complete information that the benchmark system is going to do. So when you're here, after your test is done, you'll be able to go to your Files tab and you'll have a list of tests that you have completed. And I think this version will allow you to sort of store up to 5. Potential add more. But in this case, we did a test on the 20th. So let's go ahead and upload that test. So when we hit upload, we will see that it's going to upload that test. So the way it works is that it actually sends that information over to the Sun Fun Kits website. So once that information is sent over to the Sun Fun Kits website, you'll have a new button that says View. So when you hit View, it's going to open up our website, and you can get a detailed view of the discharge test. And it's going to take a little bit to render it the first time, but you can sort of see the details here. And there's going to be more details that you would normally be able to see in the app. We did it this way because this is a URL that you can send to anybody. You can literally copy the URL and send it to anybody. So if you have a problem with your battery, you can take the test, send us the URL, and we can look at it. But anyway, let's see what we have. So we had measured this test at around 4,006 watt hours, 12.91 nominal voltage, 310 amp hours as measured current. And here's some of the details. Now we've sort of broken this down up a little bit. We showed you that the nominal capacity that it measured was at 12.92 volts, which is at 310. Normally you will rate lithium iron phosphate 4-cell batteries at 12.8. So 12.8 volts, it's at 302.9, so about 313 amp hours at 12.8, or 310 amp hours at 12.92. So we sort of give you that designation. Gives you the average temperature of the BMS, average temperature of the case. We also tell you about the loss that the BMS itself is going to produce. And in our testing, about 2.12 to 2.2% of your energy is lost simply because of the BMS. So you can basically anticipate a 92 watt hour loss, which basically would be 4,988. And normal capacity at 12.8, that's actually not correct. We'll probably correct that. But this kind of shows you have like about 4,100 watt hours. It also tells you that what type of test it was. It was shareable, the total time it took to complete the test date and time. And then we actually get into sort of graphs. So you can now sort of see how your battery discharged over time, like what it started at, what it ended at, and sort of, you have a full chart of that. You can also see the amps. You can see in this case this was a 60 amp continuous test, so we put 60 amps there. If you wanted to see your amp hours, you can turn that on and it will show you that it started at 0 amp hours, and this is sort of where it ended up, and you ended up at around 310 towards the end. Same thing for watts. Shows you total watts you've done, or you can see the watt hours. So like the battery started at 0 watt hours, and towards the end it had like 4,006 watt hours. We also have temperatures. You can see the BMS temperature as it rises. So this actually was the highest of all. It got up to 105 degrees Fahrenheit. And you can see the case temperature as it went up. Then we also show you the average BMS temp and average case temp. So you can sort of see how the temperature of it was. You can switch between Celsius and Fahrenheit. So you can see it in Fahrenheit or you can see it in Celsius. Okay. Now we further break that down per cell. So in here, this is still being worked on. Some of the information is not correct. So it's saying 505 watt hours. So, we'll have to sort of correct that. But the idea is going to be very similar. And this is just dummy data for the cells. So this is not quite ready. But the graphs are ready. And you can sort of see how this individual cell voltages sort of worked. And that includes like the cell 1 volt, cell 2 volt, cell 3 volt, and sort of cell 4 volt. And normally you would see, in this case, you can clearly, if you don't want, you can actually hide them. So if you only want to see the voltage of cell 2, you can see it. So cell 2 is actually the cell that hit low voltage cutoff the fastest. So if you just view like cell 1, it was still at 2.8 versus cell 2 was the one that hit it. So you can enable and disable charts based on that, but you can sort of see how the voltage happened. Same thing for cell amps. This is pretty much going to be the same for all cells. It was this was a constant 60 amp test, so it went there. And the same thing for cell watts. The watts being generated by each cell. Again, it's not quite 100%. This is just kind of dummy data because we haven't fully finished this individual cell information yet. But when it is ready, you'll be able to sort of see, individual cell. So for now, the overall battery data and stuff will there. Some of the data is still being corrected, and we should have that. So beginning next week, we'll send out some links to people. They can download this and test it. But you'll get pretty in-depth knowledge, more than you would get from a shunt, because you're getting data directly off the BMS. So you can look at temperature settings and stuff like that. And we still need to sort of tweak the cell data a little bit. But once that is done, you'll actually be able to see each of the cell data itself. And once you have that, it'll give you sort of a better idea of how that's being calculated. But yeah, and remember, you can copy this link and sort of give it to anybody. So if you wanted someone else to view it, they could view it. And also, again, you could be running your test with your shunt while this is running. So it's not like you have to only pick and choose. This will just give you data directly off the BMS, and you can compare. Usually we're pretty close. I would say about 1 to 2 amp hours between like shunts like the Victron or some of this. We even got this June Tech shunt. Very close. This is going to be a little higher than that simply because there's a little bit of loss from the wire, but still within 1 or 2 amp hours. But anyway, expect for it sometime middle of next month, and once you have it, you'll sort of be able to try it out. All right, thank you. We'll see you in the next one.